If you could step inside the mind of an artificial intelligence, you might expect to see words floating around like in a human brain, sentences, images, maybe even voices. But that is not what is there at all. In fact, to AI, the phrase you are hearing right now is nothing more than a sequence of numbers. And here is the strange part. Those numbers are not letters and they are not sounds. They are coordinates in a kind of invisible space that only exists in mathematics. So how does a sentence like "the sun is warm" become a trail of numbers? And why does that allow AI to do things like translate, summarize, and even write poetry? Let's decode it together. First, imagine you are looking at a map, but instead of showing countries or cities, it shows meaning. On this map, every single word you know has its own address. The word cat might be somewhere near kitten and dog, but far from quantum or democracy. In the AI world, this map is called a vector space. Each word is given a set of numbers, its coordinates, based on how it is used in billions of pieces of text. If two words often appear in similar situations, their coordinates end up close together. This is the foundation of how AI hears and understands language. But before that happens, there is a bigger step, turning the messy, rich, and unpredictable world of human language into something clean and regular enough for a computer to process. That process starts with tokenization. A token is a small chunk of text. It might be a whole word or just part of a word. The AI takes your sentence, slices it into tokens, and then uses a giant table, learned during training, to turn each token into a number. These are not random numbers. They are unique identifiers that lead into that map of meaning. Now here's the fun analogy. Think of a jukebox. When you press a button for a song, you are not sending the jukebox the sound of the music. You are giving it a number that tells it where to find the recording. AI works the same way with words. It does not store cat as the letters CAT. It stores a number that points to cat's position in the web of relationships between words. But we are still not done. Those initial numbers are like street addresses. You can find the house, but you do not yet know what is inside. To get to meaning, AI uses something called embeddings. An embedding is a set of numbers that describe a word's location in that vast map of meaning. Instead of saying cat is number 15, the AI says cat is at coordinates 0.25, -0.13, -0.78, and so on, maybe hundreds or even thousands of numbers long. Each coordinate captures some aspect of meaning. Maybe one dimension relates to, is it alive? Another to, is it small? Another to, is it an animal? None of these dimensions are labeled for humans. They are discovered automatically by the AI as it trains. This is where the magic happens. Because if cat and kitten have very similar coordinates, AI can reason that they are related, even if it has never seen them in the same sentence before. It can also do math on meaning. For example, take the embedding for king, subtract the embedding for man, and add the embedding for woman, and you end up close to the embedding for queen. This is not a trick. It is a side effect of the geometry of meaning inside AI's brain. This number-based hearing is very different from how you process language. When you hear a sentence, your brain activates patterns of neurons that connect to memories, senses, and emotions. AI does not have that. Its numbers are not linked to sight, smell, or personal experience. They are pure statistical fingerprints of how words relate to each other across oceans of text. And yet, this is enough for astonishing results, because in language, meaning hides in patterns, and AI is an expert at spotting patterns. Let's take a sentence. The cat chased the mouse. In your brain, you instantly know the cat is the one doing the chasing and the mouse is the one being chased. AI figures this out because the numbers for cat and mouse have appeared in these roles millions of times in its training data. When AI hears the sentence, it's not hearing the story. It's recognizing a familiar path across the map of meaning. But here's where it gets even more fascinating. These numbers allow AI to handle languages it has never explicitly learned to translate between. Suppose it knows English and French. If it builds the same kind of map for both, it can align the maps so that cat in English and chat in French share nearly identical coordinates. Suddenly, translation becomes a matter of hopping between maps, not memorizing dictionaries. And it works for thousands of languages, including ones with completely different alphabets or scripts. You might be wondering, why go through all this trouble? Why not just store words directly? The answer is that computers cannot work with meaning the way humans do, but they are very good at working with numbers. Numbers can be added, subtracted, compared, and optimized. Meaning cannot, unless you turn it into numbers first. By converting language into numerical form, AI can apply the full power of mathematics to it. It can cluster similar ideas together, find hidden connections, and predict the next most likely word in a sentence with incredible accuracy. The cool part is that this process works not only for words, but also for images, sounds, and even video. In each case, the AI turns the input into a numerical representation, a point in some high-dimensional space, and then processes those points with the same machinery. This is why an AI that has been trained on both text and images can generate a picture from a sentence. The numbers representing the sentence can be mapped into the same kind of space that the images live in, allowing the AI to bridge from one domain to the other. But here's the mind-bending twist. The AI does not see a cat picture the way you do. It does not see fur, whiskers, or eyes. It sees a cloud of numbers that it knows from training corresponds to images humans label as cat. In other words, the AI's entire sensory world is made of coordinates. To it, everything, words, pictures, sounds, is just a different flavor of numbers. That is why we say AI hears words as numbers. It has no ears, no eyes, no tongue. It lives entirely in the realm of mathematical relationships, and yet it can navigate human language with skill that sometimes feels eerily natural. The irony is that by stripping away everything sensory and keeping only the structure, AI has found a shortcut to handling meaning in ways that our biology never could. Here is where our analogy of a map becomes even more powerful. In everyday life, if you travel through a city often enough, you build mental shortcuts. You know which streets connect, which ones are dead ends, and where the best route lies. AI builds something similar, but instead of streets and intersections, it has mathematical pathways between numbers. When you give it a sentence, it plots a path across its map of meaning, moving from one coordinate to the next, predicting which point should come next. That's all prediction is for AI, moving to the next most probable location in this invisible space. But unlike you, AI can explore billions of possible paths in fractions of a second, instantly discarding the ones that don't make sense. This is why it can auto-complete your sentence or write entire articles with coherent flow. It is not recalling exact sentences it has seen before. It is navigating a landscape of numbers and selecting a path that fits the patterns it has learned. And here's something that might surprise you. AI doesn't think of words as isolated dots on this map. It represents whole phrases and sentences as points too, by blending the coordinates of each token together. This allows it to capture not just the meaning of individual words, but the combined meaning of how they're used together. For example, hot dog as a phrase gets its own point in the space, far from hot and dog taken separately. This ability to represent context is why AI can handle ambiguity. When you hear the word bank, your brain uses context to decide if we're talking about a riverbank or a financial institution. AI does this too, but mathematically. It looks at the coordinates of the words around bank and shifts its interpretation to the correct spot in its meaning space. Now think about how revolutionary this is. Once language is transformed into this consistent numerical form, AI can compare ideas that look completely different on the surface but are structurally similar in meaning. That's why it can recognize that a quick brown fox jumped over the fence and a fast tan fox leapt over the barrier mean essentially the same thing, even though the words are different. It's not matching letters, it's matching geometry and meaning space, and this geometry is huge. A typical AI language model works in hundreds or thousands of dimensions. That's impossible for you or me to picture. We live in a three-dimensional world. But for AI, this vast number of dimensions allows it to store incredibly detailed information about relationships between concepts. Every extra dimension is like adding another layer of nuance. One might represent emotional tone, another could represent formality, another could capture associations with specific topics. This is also why AI can switch between writing a technical report and composing a poem. The numerical patterns that correspond to each style occupy different regions of this space. When you give it instructions, you're essentially telling it which neighborhood to explore. Here's another twist. Because numbers are universal, AI can connect different types of information that would seem unrelated to us. For example, a model trained on both images and text can place a picture of a cat and the word cat in nearby positions in a shared space. That means it can look at an image, find its coordinates, and then hop over to the region of the space that contains words with similar meaning. This is the bridge that allows it to caption images or even generate art from text prompts. You can start to see the beauty here. To AI, all sensory inputs, language, vision, sound, are just different shapes in the same kind of space. Once they're all converted into numbers, they can be combined, compared, and transformed freely. This is also why AI can learn new skills quickly if they fit into the same structure. If it already knows the relationships between thousands of animal names, learning the name of a new animal is as simple as adding one more point in the right spot. What's remarkable is that this whole process relies on mathematics so pure that the AI doesn't need to understand in the human sense to be effective. It doesn't imagine a cat. It doesn't smell the rain. It doesn't feel the warmth of the sun. Yet, by manipulating numbers that encode relationships between concepts, it can produce language that makes us feel like it does. This can be a little unsettling. We tend to associate language with thought and thought with consciousness. But AI is showing us that you can separate the structure of language from human-like awareness. You can have skill without sensation, prediction without perception. And in a strange way, that makes it even more impressive, like watching a pianist play a perfect concerto without ever hearing a note. Now let's bring this down to real life. Every time you type into a chatbot, issue a voice command, or even see auto captions on a video, this transformation from words to numbers and back again is happening behind the scenes. The AI is hearing your request as coordinates, running mathematical operations on them, and then speaking back to you by turning other coordinates into words. Understanding this process can change the way you use AI. You start to realize that if you want better answers, you need to guide it to the right place on its map of meaning. The more precise and clear your instructions, the easier it is for the AI to navigate to the exact region of space you want. And that is a skill worth having. Because in a world where more and more of our tools hear us in numbers, those who know how to speak in a way machines can map effectively will have an edge. So next time you interact with AI, remember, to you, words carry sound, images, and emotion. To it, words are locations in an invisible, high-dimensional landscape. And in that landscape, poetry, programming, and pizza recipes are all just different journeys between points. If you found this peek into the secret life of language inside AI fascinating, imagine how many more everyday things hide stories like this. Stories where the ordinary becomes extraordinary once you see the hidden machinery. That's exactly what we explore here on How It Actually Works. So if you want more keys to unlock the hidden side of the world, make sure to like, share, and subscribe. Your curiosity is the map, and we're here to help you explore every coordinate.